好，繼續。咁我今次擺呢度啦嚇。嗱，今次咧就 example 4嚇，咁就會係喺大家嘅 page 27。好 ，example 4。Okay, force between spheres. Okay, when you look at this one, the question asks you what is the force between spheres. It means that you should apply the Coulomb's law. But before you apply the Coulomb's law, you should identify all the unknown symbols. For example, QQ. Okay, when you look at this question, QQ should be positive 3, Q and negative Q. And also, you should know that the distance between them, otherwise you cannot calculate. And look at this. Originally, the distance, the question haven't given you that, but tells you that the force between them is F. Now, both together touch each other, it means that charge sharing. And return to the initial position, it means like that, and then ask you what is the force. Okay, then this case, what should you do? Here we have two different cases, two different situations. Focus on the first one. Here, positive 3, negative 9, and the distance is unknown. We can say that unknown R. Then the force should be F. Here, you should try to write down it. Okay, let me to find out the pencil. Okay, here, pencil. This one, F, should be the bracket 1 over 4 pi epsilon naught, and also the QQ. One is positive 3Q, the other one is negative 9Q. The distance is unknown R. Then we can set up this equation. But when this one both together, charge sharing, focus on it. Negative 9 and positive 3, add them together, should be negative 6. And they are identical. So after charge sharing, this one should be negative 3 and negative 3. And the question asks us, what is the final F? I say that F dash should be the bracket, and R should be the initial position. It means that the same, but the charge are not the same. One of it is negative 3Q, the other one is negative 3Q. Then what should we do? We want to find out F dash. Okay, this one will be the mathematical skills. These two equations over each other. Then we can, in terms of F and R square, cancel it, bracket cancel it, QQ cancel it, only focus on the value. This value, the side, of course, you can negate it. This one should be 9 and 3, 27. And this one, 3, 3 is 9. It means that 3 to 1. The force will be smaller than before, only 1/3 of original. Okay, now let us to look at the answer. The same, 27. One over 3. Okay, so this one 27 and 9, so 1/3 of original. Okay, next one, example 5, hydrogen atom. In basic chemistry, you should know that hydrogen is a very small element, the first element, only one proton in the nucleus. Around it we have the electron. Positive and electron, between it we will have the electric force. In this question, we want to find out the value of the electric force between electron and the proton. And this data tells you that the mass of proton, mass of the electron, and the radius, the diameter of the orbit. Try to put everything into it and then find out what happened. Estimate the magnitude of the electric force experienced by the electron. One more item is electron. What is the value of it? The charge in it will be 1.6. This one times 10 to the power negative 19. And also for the proton will be the same amount of the charge but opposite side. This one will be the radius square. This one will be the bracket. This one finally will be this value, very small. Okay. Part B. How about the weight? We use G is 10 instead of 9.81. mg, okay, is 10 to the power negative 30. So compare it. The actual force is very large compared with the gravitational force. Okay. How about example 6 on your page 28? Neutral points. What's the meaning of neutral point? In this example, you will know that what's the meaning of neutral point. Here, we have two charges, Q1 and Q2. They are positively charged, but different in magnitude. The distance between them will be 2 meters. Now we have third charge, Q, located nearby where it experiences no net force. This one is the mechanics. Low net force means that no force acting on it, maybe. But usually, net force means that the total forces. On the other way one, if there's no net force, maybe one force on the left hand side, one force on the other side, right hand side. They are equal. Add them together will be 0. I think this example will be this case. I put the charge here. This one may be positive charge or negative charge. Maybe, okay? I say that may be positive. Q1 and positive charge Q repel each other. At the same time, this positive charge and Q2 repel each other will be in this way. These two forces may be equal in magnitude. Then the net force will be 0. Now, what's the question? Where is Q? Okay, maybe here, maybe here. We want to calculate. Okay, what's going on? Go back to here. This one is positive 30. What's n? N means that 10 to the power negative 9, quite small. This one is positive 12. Now, try to understand. Both forces should be the same, but you can see that this charge is greater than this. It means that the effect of it is larger than this one. Q1 is stronger than Q2. In order to have the same amount of the force, where is the position of this charge Q? Should be near to Q1? Of course not. This one should be here. This one greater in charge, even longer in distance, it can provide same effects compared with this. This one, the charge is smaller, even smaller in distance. The force is not very great. Then they will balance to each other. Okay, so without any calculation, you should think that the third charge Q should be here. Okay, but what is the actual value? Of course, you should calculate. Try to find out this force and try to find out this force, balance it, then you can find out this position. Now go back to the question, the answer. This one, two sources, two forces. Forces by Q1, forces by Q2. One is F1, the other one is F2. Their magnitude should be the same. Okay, opposite direction equal in magnitude. Like that. Okay. Opposite direction. For your textbook, you may think that here, but you can find that this one must be wrong. If this one is positive charge, Q1, repel it. Q2, repel it. These two forces cannot balance each other. Net force cannot be 0. Similar one, this one also impossible. This one impossible. Both of them should be opposite in direction. Then we have chance to balance it. What if Q is negative? the same. Okay, also lie between it. How about the magnitude? You should try to find out the formula, let it out, and the other one should be 2 minus 0. 2 means that meter. 2 meter between Q1 and Q2. In order to find out the value, balance it, the bracket, you can think that should be a constant, cancel it. Q will be the third charge. Q also cancel each other. After the calculation, this one is the quadratic equation. Do not do it by your own. Try to use calculator to do it. Okay, quadratic equation. Finally, the answer should be 1.23. Okay, from Q1. A what if question. How does the location Q change if two charges are both double? Both double. Then what happened? Okay, at original position, net force on Q is still 0. Okay, go back to this formula. This one, Q1 is double, Q2 is double. It means that 2 and 2 cancel it. Final answer will be the same equation, same answer. Okay, the location of 0 net force remain unchanged. How about B? If only Q2 is increased, it means that the importance of the Q2 will be larger than before. Then what happened? Okay, at the same time Q1 will keep the same. Then at original position, now F1 is less than F2. To cancel out these two forces, Q should move, okay, towards Q1. In order to make F2 reduce, F1 increase. Then should be shift towards Q1. How about the third one? If Q2 is negative, okay, negative instead of positive, Q1 remain unchanged. What happened? Focus on the direction of the force. If this one is negative, okay, if negative, then if this one is positive, positive repel each other, positive, negative will be attract each other. But here, too far away, okay, too far away, they may not cancel each other, okay, because F1 always greater than F2. On the other way one, in between, what happened? Put it here, positive, repel, positive, negative, attract. They are the same direction. They cannot cancel each other. Here, impossible. How about this? This one, because Q2 is less in magnitude. This one is greater in magnitude. Greater in magnitude, even further away, it can provide the same effect. Now put the test charge here, positive, repel each other. Positive, negative, attract each other. Because this one is greater in charge, the effect will be greater than Q2. Even further away, it can produce the same effect. Then it has chance to balance it. It means like that. This region is possible. Okay, it shifts to the right of Q2. Okay, that's all.